Hello my friends, welcome to this new practical activity on this time the naive Bayes classification model. We already implemented logistic regression, k-nearest neighbors, SVM and kernel SVM, and so far the best accuracy we've got with these four models is 0.93, which we got with both k-nearest neighbors and kernel SVM. And now we're about to implement a new classification model, the naive Bayes one, a very well known and widely used, so you definitely want to have it in a toolkit. And so the big question is, will we beat that best accuracy of 0.93? And now let's do this. Let's start the implementation of naive Bayes. So we're going to go into this folder and we're going to start with Python as usual. And inside this folder, you will find two files, the naive Bayes implementation in the IPYNB format and the same social network ads dataset, which I will quickly re-explain. So this is a dataset containing 400 customers. Each row here represents the customer. And for each customer, we get the two features, age and estimated salary, with which we are going to predict the dependent variable purchased, which tells if yes or no the customer bought the SUV. So 0 means that indeed the customer didn't buy the SUV, and 1 means that the customer bought the SUV. Alright, so we're going to train a new classification model to understand the correlations between these two features, age and salary, and that dependent variable purchased in order to predict the customers that will buy the SUV. And once we get these predictions, we will target these customers on social networks with some beautiful ads of this beautiful car. Alright, so that's the same story, and now we're going to start our implementation, and I can't wait to see if we're going to beat the accuracy, and I can't wait also to show you the visualization results at the end. Alright, so right now it is loading and laying out the notebook, and here it is. Here is a naive Bayes implementation, still resulting from the same classification template which we made in the first section of this part 3 when implementing logistic regression. So basically all the cells here are the same as in this logistic regression implementation or classification template. The only cell that will change will be, the one where we build and train the classification model, meaning this one. That's the only cell that we will re-implement ourselves because all the rest is the same. But this notebook is in read-only mode, and therefore in order to re-implement that cell, we need to create a copy of this notebook by clicking Save a Copy in Drive. And as you can see, this will create a copy in which we will be able to re-implement that cell. All right, so once again, laying out the notebook, and there we go. Here is our copy on which we are authorized to modify anything, and especially that cell we want to re-implement. So I'm scrolling down here to find it. Here it is, training the naive Bayes model on the training set. So let's immediately remove that cell because I want you to re-implement it from scratch as if we had no idea on how to implement this. All right, let's create a new code cell. And now your turn. I want you to train your machine learning independence by figuring out by yourself how to indeed build and train that naive Bayes model on the training set. So of course, to do this, you have several options. You can directly type in the search bar of Google or Bing, naive Bayes scikit-learn class. Okay, or you can navigate the scikit-learn API, which is right here, in order to find that class which we need to build our naive Bayes model. And my personal recommendation is to try with the second option because indeed this will get you familiar with this API, and the more you get familiar with it, the better. Okay, so please press pause now, try to find this class and then try to build this naive Bayes model and train it on the training set. And now in 2 seconds, we will implement the solution together. All right, let's do this. Let's build this naive Bayes model with scikit-learn. So the API is huge and this is organized in alphabetical order. And so the first thing we'll try is to find, a module called maybe naive Bayes, right? Just the name of the model. So we will scroll down to N, the letter N, and we'll see if we get naive Bayes somewhere or something close to it. Let's see, linear model, manifold learning, metrics. We're getting close, and Gaussian mixture models, model selection, multi-class. Wow, there is a lot of M. Okay, perfect, naive Bayes. So let's click this, naive Bayes. All right, and so the module indeed is naive_Bayes. And among these models, according to you, which one are we going to take here? That's a good question actually. Well, in fact, the classic one and the one that you learned in the intuition lecture is of course this one, the Gaussian naive Bayes, Gaussian NB. And that's exactly what we'll use to implement our naive Bayes model. Alright, so the name of the class is Gaussian NB, and this time the good news is that we won't have to worry too much about the parameters because there are actually only 2 parameters. And so here, very simply, we will just call this class without inputting any parameters. So that's super easy. Let's copy this and let's go back to our implementation, the copy one. Let's paste that here. Let's remove this little thing here. And now you know how to adapt this. We need to start with from, the naive Bayes module of the scikit-learn library. And then here you add import. There we go, that Gaussian NB class.